What is going on, team? It is your friend Austin here with APSpace, and today we are going to configure the USB software on a Photon 3 V1, which has a ATSAME70N21B-CNT microcontroller on the PCBA. So we're using a Microchip Technology microcontroller board, and we're going to configure the USB software today. So to begin, we are going to go to our schematic, and this is our official Photon 3 V1 schematic. V1 is for version 1. And this is effectively how you do the pinouts for a board if you are creating your own PCBA that has a Microchip Technology microcontroller on it. So this is where you connect the plus 3v3s, the plus 1v2 lines, essentially, or nodes, however you want to think about the traces, or the pinouts, and then this is the microcontroller, right? So that's a part number for a microcontroller, right? So ATSAME70N21B-CNT. This is our microcontroller. This is our power supply, and this is converting plus 5 volts to plus 3v3 volts, and the circuitry here is what is selecting the plus 3v3 volts for us here with this voltage divider. This same power supply, same part number, U3, is turning plus 5 volts into plus 1v2 volts, but we have a different value for our voltage divider, which is R4 and R5 here, right? So we have another power supply that's turning plus 5 volts to plus 1v2 volts. We are going to our connector page, or one of our connector pages that has our programming connector, 2 I/O connectors, 1 USB-C connector here. This is our camera module controller connector and our audio codec controller connector. So everything that's labeled here is for an image sensor or for a camera or for something that can do video. This protocol here is something that interfaces with an audio codec component, essentially. So this is what you would plug in to a device that has image sensors and audio input and output devices, essentially. So we can plug in audio and camera applications or boards to this connector here. And you have UART. You can actually plug in an SPI. This has an SPI somewhere in there too. If you reference this datasheet here, and that's J5. Some more pull-up resistors and decoupling capacitors. And you have the final page, which is a USB to UART bridge here. And this has a decoupling capacitor here as well. And then this 4.7 microfarad capacitor. We have a 16 megahertz crystal oscillator. We have a USB-C connector, a inverter, and a 1 mega ohm resistor. So this is the schematic. If you're building a evaluation board, this is a pretty good reference to show anyone who's trying to build a PCBA how to interface with a Microchip Technology microcontroller. So here's a solution, and this is the whole board. In summary, here's the microcontroller, power supply, connectors, another connector, resistors, capacitors, USB to UART bridge, connector, oscillator, inverter, etc. So that's the schematic. And now that we showed you guys the schematic, we'll show you the board. So the board looks like this. And nothing more to it. That's the board, right? So this is J5, J1, J2, J3, J4, J5. This is the microcontroller, power supplies. You get the gist. So that is our PCBA that is designed for audio and image sensor application. So this connector here is designed to interface with a camera, something that is an image sensor that can do photos or video. And this also has a protocol that is specifically made for an audio codec controller, which does audio input and outputs essentially, right? So the audio codec controller protocol goes from this microcontroller to an audio codec controller, which goes to a microphone and a speaker essentially. And that is what this is built to get plugged into, essentially. So we have our board here. We are plugged into J3. We have a Atmel ICE programmer that is plugged into J3. We're specifically using this kit with the squid cable and this right here. So that is what we have plugged into J3, and we are plugged into J6, power up the board, and we have the USB-C connected to the laptop via J6. And now that we have the hardware determined, what we need to do if we're starting from the very beginning is we need to go to the schematic and we need to reference our USB to UART bridge part number. So it is the CP210. That is a Silicon Labs USB to UART bridge. So I'm going to go to CP10 bridge. Click on this page here. We go to downloads. We go to Universal Windows driver. We have downloaded the driver here. I've downloaded this driver a few times, so I have the 2 there. We copy and navigate to the APSpace folder, software, Photon 381, the Windows Universal driver. Paste that in there, and then we'll extract all, extract. I already have that in there, so that was just for sake of me showing you guys, but we'll just use this driver for the sake of the simplicity of the video. And then once more, we want to go to instructions. Okay, that was another product I was working on and goes out of there. We now want to install the driver with the manual install. So we navigate to this section. We go to Device Manager. Then we go to ports and COM ports. We already have it installed, so what we want to do is uninstall the driver, uninstall. Okay. So we have uninstalled the driver, and what we want to do now is reinstall the driver. And we can navigate to our folder, and we go to manual install. Using Windows File Explorer, locate the driver folder. This is the driver folder. This is step 1 of the manual install instructions. Step 2 is right-click on the syllabser.inf file and select install. That is referring to this file. And we follow the instructions exactly. So we'll right-click and then we'll select install. Do you want to allow this app to make changes to your device? Yes. Operation completed successfully. Okay. And then what we want to do is go back to our device manager, and we can unplug the board. Then we have our Silicon Labs CP210 USB to UART bridge COM3 established. It's more, and we are plugging into J6. It's where the USB to UART bridge communication is happening. And then once we now have uninstalled and reinstalled our CP210 USB to UART bridge driver, we can now finally go to NPLab X IDE. And what we now want to do, now that the driver is installed on our USB to UART bridge, is we want to program the microcontroller as the Microchip Technology microcontroller, right? And we want to first make a project that we can transmit the data from the microcontroller to the laptop, and then receive the data to the microcontroller on another project. So what we want to do is create new projects, go to File, New Projects, and then you go to Microchip Embedded, Application Project, go to Next. We're specifically using a 32-bit MCU SAM device. We have to select our device, which is a ATSAME70N21B. And then we're using our Atmel ICE debugger. And then once that is all over here, we go to Next. We're using the XC32V4.40 compiler. Just like that. Go to Next. And then you create the folder. Our software will be here. We want to create a new folder. This is photon3_v1 _e_j6 _tx4. Got it there. Photon3v1 USB1 J6 tx4. We open that and then call the project the same thing. It's fine. Just organized here. Okay. So project name, project location set, we finish the configuration. And we're going to try and do the easiest way to go about this, and then we can get more complicated as we progress. So wait for the project to load. And something to note is that you need to make sure your resource manager tab is displayed here. If you do not see the resource management tab, what you can do is you want to go to Window, MPLAB Code Configurator V5, and you open and close this. You'll have that open. You can close the window by doing that. You can reopen it by going to Window, MPLAB Code Configurator V5. You reopen the window. So we are back to where we need to be. And we have the resource management tab here. And what we'll begin with is the clock configuration. This can effectively all remain default. We don't need to mess with this at all because we don't need to. The quick overview here, though, is 300 megahertz processor clock is how fast the microcontroller runs. 12 megahertz main RC oscillator. We keep this as main RC oscillator. The main crystal oscillator is enabled here. And that is all we need to know about. And then we want to go to end configuration and sort by ports. And now we actually have to reference our schematic. And this is where our UART communication is happening on pin PD15, which is RX2 on our microcontroller. So navigate down to PD15, user 2, RxD2. That is correct on our schematic. That's good news. PD16 and TX2. PD16, TX2. And we can configure all of this later if you want to add to this, but for now, all we need is just to enable the function for receive and transmit. That is effectively complete. And then we want to go to our device resources. We go to peripherals. This is a USART. This is USART 2. If you need to differentiate between USART and UART, that is in the datasheet. That is here in signal description. Might as well go to that while we're discussing the topic. TXD, RxD is USART transmit data and USART receive data. It's right there. And go to configuration options. We just make sure our baud rate is set correctly. We're at 115,200 baud rate. And then that can all remain default. You don't really need to edit anything there for the sake of displaying video. And then there's all that is necessary for the transmit, and then we generate the code and make sure you click on generate there. And then you go to source files, main.c, and then this is where our project is, right? So that you guys don't have to see me type all of this, go to file, projects, and then what we want to do is copy and paste our variables. That's copy and paste here. And then we need this here. And put this within the while loop. And then our software is pretty much completed. I've simplified that by using blocks and effectively have made this a massive shortcut, but that's all you need. This is the string we're sending from the microcontroller to the laptop. This is potentially useful because this is how you store the string of data APSpace 1 into an exact memory address, which is this memory address, into the memory of the microcontroller. So that's how you put a data set into an exact memory address with this declaration here. And then we're sending the string array1 tx1 to our laptop every approximately a second. This is a fast way to make a delay loop here, and then we're just sending data every so amount of time in the delay loop. And then we file, save all, and then debug the main project. You see our part number. It's erasing and running, and goes out of here, and the program is effectively running, programmed and running essentially. So what we need to do now is go to TerraTerm, open, and sorry. Okay. We re-go into TerraTerm, open a new window, go to serial, COM3, Silicon Labs. It's not working because our baud rate's not set correctly. We use 115200 setting, and huzzah. We have communication that is happening with our microcontroller sending APSpace 1 with a new line and a carriage return. at the end to our terminal window. So we have now successfully transmitted data from our microcontroller to our laptop. How do we receive data? How do we do that? So what we want to do now is we can actually we can stop the debugging and okay, so we just made the transmit software. Right now we need to make the receive software, go to file, new projects, application, projects, microchip embedded, next, say 32-bit MCU, SAM device, it's an ATSAME70 and 21B. Have an ICE programmer, XC32, the 4.40 compiler, the next, to navigate to where we want the folder. This is Photon 3, 1, 6, RX. There, into the folder, there, need project 3, 1, 6, project 3. Finish configuring the projects. And then we'll go through this iteration a bit faster. We want to do the clock configuration and all of this, make the default. Go back to project graph, we go to pin configuration, we sort of order by ports. We want to go to PD15, and then go to UART2, RxD2, PD16, and go to UART2, TXD2, and then that's how our pins need to be configured. And then what we need now is to go to Harmony, our device resources, go to peripherals. We are using UART2. That is officially added. Go to configuration options. Here. And then make sure we're at 11520 baud rate. Goes up there. And we don't need to configure anything else. Go to generate. And now is when we have to put our thinking caps on, because this is, you have to look at the data in the microcontroller now, not it would be data, right? So this is our main.c, that is our main file that has been generated. We want to open a project, and we want to open Photon 3v1. We want to go to Photon 3v1, USB, G6, RX1, the open projects, and go to source files, main.c, and we need this for our declarations. There. And then all we need is just these two lines here. You put that within the while loop. And then that's really all we need. We just need USART to read, and then we're reading for APSpace 1. We're sending the string APSpace 1 from our laptop to the microcontroller, and this is the function that receives the data with a USART. And we have a no operation function here so that we can put a breakpoint there later. And close out of this project, use that as the project we opened to copy and paste from. We save all there. Once more, and then before I debug this, we're going to debug mode. I'm sure where Grace find all this stuff. So we added USART we added the USART to library into our resource manager, right? Management. Where you find all that stuff is in classes, and then all of the functions are listed here. So if you're looking for a function and you don't know exactly where it is, or if you don't conveniently have technical support video, you can go into classes, and then your USART to write function is here, and your USART to read function is here. And you can actually go to the function and you can see how the function is written, which can be enormously helpful if there's comments, right? There is comments here, which can be helpful. And it's a pretty simple function, right? I mean, you only have two arguments. You have a pointer to buffer, and you have a constant that's just the size of the array, basically. And that's what we have in our C file, is that we just have, we're passing by reference array1 underscore rx1, and we have the number 8. So the size of 8 bytes and the reference to the empty array, array1 rx1 of size 8. And then that is all set. We want to go to debug main project. The build was successful. And then you can see the output here. We're watching the debugger erase and then reprogram the memory. And we are almost to how we can see the data being received, right? And we see array1 underscore rx1 is at this address, and there's no value, right? And then there's just zeros, and where the value is, where the contents is all zeros, and this is the address in memory, right? And it's supposed to be like that because we haven't sent any data yet. And if we would like to send data, we need to go to char term, you need to go to serial, and then COM3, select OK, go to setup, serial port, go to speed, and then go to 115200, go to new setting, and then what we need to do is go to File, Send File, and then this APSpace 1 output file 1 is just a text file and it says APSpace 1 in it, right? So we'll bore you guys to death with that. And then once you click open, we effectively have sent the data to the microcontroller nearly right when you click open, right? So you don't see that here because we didn't send any data to our laptop. We sent the data to the microcontroller. And if you want to see the data in memory, what we actually have to do is set a breakpoint. So we can set a breakpoint by actually clicking in the column here, and we set the breakpoint on the no operation function line. And then what we can actually do is highlight the variable and then go to program memory. And then we can go to data memory, address on the filter, and then data. And then our watch has now updated since we clicked out of the page and then basically like refresh the page basically. And our address is, this is the address. So this is where in memory we're looking. We're looking at address hex 204000A0, and this is the value of the address. Okay. So if we want to see in data memory, this is kind of the most organized way to look within data memory. And we see that here within the data memory, right? So at 204000A0, we have APSpace 1 now displayed within data memory as well. And this section can be very helpful to debug and see exactly where the data is. If you want to know exactly where every single byte is of your data, then this is where you go. And you can even check your registers. You can check the assembly code. You can do all that in here, which is pretty good. You can see all that in there. And then mission accomplished. You have successfully configured the USB software on a Photon 3B0, and you can transmit and receive data on a Photon 3B1 with a Microchip Technology microcontroller. You guys all have a wonderful day.